Let's talk about the basic of rotational dynamics. In this particular video, we will talk about the angular displacement, angular velocity, and angular acceleration. When we are talking about the angular displacement, the definition for the angular displacement is the shortest angle between the initial and the final position for an object in a circular motion around a fixed point is known as the angular displacement. When we talk about the SI unit of the angular displacement, so the SI unit is radian. Suppose we are taking a circle with a radius r and with the initial position is given by A and the final position is given by B. So in this, when we move from A to B, then the circle will describe a circular motion in which S will be the arc length and the theta will be the angular displacement. So we can write that theta, which is nothing but the angular displacement, as a S by R. So let's talk about the next topic is angular velocity. So the angular velocity has a definition of time rate at which an object rotates or revolves about an axis or at which the angular displacement between two bodies changes. So basically the SI unit for this, it will be the radian per second, because the theta has a radian and the time as a second. So let's talk about the formula for this. So the angular velocity connotation is given by omega. So omega is equals to d theta by dt. And let's talk about the next topic, which is the relation between the angular velocity and linear velocity. When we talk about the angular and linear both velocities, so the linear velocity, that v is equals to omega into r. This all things which we have taken is in the scalars form. Let's talk about the relation between the angular velocity omega, time period capital T, and the frequency small n. So when we will relate the omega and the time period t, so we have got that the value as omega is equals to 2 pi upon t, and we know that the 1 by t, the reciprocal of time period, is nothing but the frequency. So we can write omega as 2 pi n. Let's talk about the next topic, angular acceleration. So the angular acceleration is a time rate of change of the angular velocity and usually designated by the alpha and expressed in the radians per second square. So we can say that the unit is radian per second square. When we talk about the formula, so the angular acceleration is given by alpha. So the alpha can be written as d omega by dt, where d omega is change in the angular velocity and d theta is change in time. So we can also relate with the theta, that is our angular displacement. So it can be written as d square theta by dt ka square. So coming with the next part, that d omega by dt can also be written as omega 2 minus omega 1 upon t2 minus t1, where omega 2 and omega 1 are the angular velocities final and angular velocity initial respectively, with the omega 2 and omega 1, and with related to that t2 and t1 is final minus initial time period. Coming with the next part, when we relate with the omega, we have seen in the last topic only that the omega is nothing but 2 pi n. So at the place of omega 2, we have substituted 2 pi n2 minus omega 1 के place where we have substituted 2 pi n2, and the same thing t2 minus t1 in the denominator. When coming with the next topic, like next step, we have got that 2 pi as a common and we have written n2 minus n1 upon t2 minus t1. Let's come with the relation between the angular acceleration and the linear acceleration, which is a. So let's talk about this a and alpha ka relation. So a is equals to the linear acceleration is r times of the alpha. So this was the basic concepts about the rotational dynamics.